Getting to know perimeter networks. Perimeter networks are small networks that usually consist of only a few servers, which have some form of access to the internet. Generally, the term perimeter network is synonymous with DMZ. You should be able to identify DMZ and its purpose in an organization, as well as know how to implement a basic DMZ. Certification ready. Can you describe the various security zones? Objective 1.2. A perimeter network, also known as a Demilitarized Zone, DMZ, is a small network that is set up separately from a company's private local area network and the internet. It is called a perimeter network because it is usually on the edge of the LAN, but DMZ has become a much more popular term. The DMZ allows users outside of the company LAN to access specific services located on the DMZ. However, when set up properly, those users are blocked from achieving access to the company LAN. Users on the LAN will quite often connect to the DMZ as well, but without having to worry about outside attackers achieving access to their private LAN. The DMZ might house a switch with servers connected to it that offer web, email, and other services. Two common configurations of a DMZ include back-to-back configuration. This configuration has a DMZ situated in between two firewall devices, which could be black box appliances. An illustration of this is shown in Figure 1.18. In this configuration, an attacker would have to get through two firewalls in order to achieve access to the LAN. Figure 1.18, a back-to-back DMZ configuration, internet, email, web, LAN. 3-leg perimeter configuration. In this scenario, the DMZ is usually attached to a separate connection of the company firewall. So the firewall would have three connections, one to the company LAN, one to the DMZ, and one to the internet, as shown in Figure 119. Once again, this could be done with a firewall appliance or server. In this configuration, an attacker would only need to break through one firewall to achieve access to the LAN. Although this is a disadvantage, technologies like network intrusion detection prevention systems can help alleviate more security issues. Also, one firewall means less administration. Figure 1.19, a 3-leg perimeter DMZ configuration, firewall, internet, LAN, DMZ, web, mail. Identifying network topologies and standards. Networks need to be situated in some way to facilitate the transfer of data. Topologies are the physical orientations of computers in the LAN. Access methods are ways that the computers will send data. The most common of these is the client-server-based Ethernet configuration, although there are others. In order to build a LAN, you must first plan out what topology or topologies will be used and what type of access method will be implemented. Access methods tend to be not so clear and definite. So let's begin with discussing network topologies. Identifying network topologies. Network topologies define the physical connections of hosts in the computer network. There are several types of physical topologies, including bus, ring, star, mesh, and tree. For the exam, you should know the star, ring, and mesh technologies. We'll throw in the tree topology known as hierarchical star for good measure as well, because it is considered by many as an extension of the star topology. We will also identify logical topologies because they are characterized differently than physical topologies. Certification ready. Can you describe network topologies and access methods? Objective 1.5. In this exercise, you examine the following physical topologies: star, mesh, ring. By far the most common topology is a star topology. When a star topology is used, each computer is individually wired to a central connecting device with twisted pair cabling. The central connecting device could be a hub, a switch, or a Soho router. This is the type of topology you will usually use when implementing networks. Identify topologies. To identify topologies, perform the following steps. Examine Figure 1.20. This illustrates a simple star topology. Notice that it is like Figure 1.1 and 1.2 earlier in this lesson. Indeed, those other figures also illustrate star topologies. Note that the hub in the center of the figure connects each computer by a single cable. This way, if one cable is disconnected, the rest of the network can still function. This is a standard physical topology for an Ethernet network. Figure 1.20, illustration of a star topology. Star topology. Identifying network topologies and standards. Examine your own computer network. Check to see if it meets the characteristics of the star. Namely, is each computer connected to a central connecting device? Are they individually cable to that device? Add to your network documentation the fact that it is a star if you identify it as such. In the old days, we had what was known as the bus topology. This is now deprecated. This is a topology for a local area network, LAN, in which all the nodes are connected to a single cable. The cable is called the backbone. If that backbone becomes broken, then the entire segment fails. Bus topologies are relatively easy to install and don't require much cabling compared to the alternatives. However, part of this idea was passed on to star topology. For example, two individual star networks can be connected by the central connecting device to create the star bus topology. This is done by daisy chaining or stacking one or more hubs or switches, usually by a special medium-dependent interface MDI port. This is where the bus part of star bus topology comes in. You will learn more about MDI ports in lesson 3. The problem with the star bus topology is that it is based on a stacking concept. This can pose organizational problems, and it is not the best use of bandwidth. A better solution in most scenarios is to use the hierarchical star shown in figure 1.3 earlier in this lesson. In the mesh topology, every computer connects to every other computer. No central connecting device is needed. As you can guess, a true or full mesh requires a lot of connections, as is illustrated in figure 1.21. Examine the figure and calculate how many connections would be needed as each computer to ensure full mesh configuration. Figure 1.21, illustration of a mesh topology. Mesh topology. Lesson 1, understanding local area networking. The number of network connections that each computer will need is the total number of computer minus 1. As you can guess, this type of topology is rare, but is necessary in some lab situations and fault-tolerant scenarios where data needs to be replicated to multiple machines. A lesser version of this topology is a partial mesh, where only one or a couple of computers on the network have a second network connection. For example, if a computer needs to replicate the database to another computer but doesn't want the connection to be bothered by any other traffic, a computer with two or more network connections is known as a multi-homed computer. Lastly, we have the ring topology. Examine figure 1.22, which illustrates how computers are connected in a ring fashion. Illustration of ring topology. Ring topology. In a LAN environment, each computer is connected to the network by way of a closed loop, which was historically done with coaxial cable. When it comes to today's LANs, the use of coaxial cable has been deprecated. However, when applied to other types of networks, like token ring or fiber distributed data interface (FDDI), it takes on a different meaning, that of the logic topology. A logical topology describes how the data is actually sent from one computer to the next. Token ring and the FDDI utilize a token passing system instead of a computer broadcasting the information to all other computers on an Ethernet network using a star topology. Token ring and FDDI computers wait to obtain a token. The token is passed from computer to computer, picking up data and dropping it off as needed. Most of these networks have one token, but it is possible to have two in large networks. The biggest advantage of token ring is that collisions become a non-factor. A collision is when two computers attempt to send information simultaneously. The result is signal error overlap, creating a collision of data, making both pieces of data unrecoverable. In Ethernet networks, data collision are common due to the whole idea of broadcasting, but in token-based systems, there is only one item flying around the network at high speeds. It has nothing to do to collide with. Disadvantages include cost and maintenance, plus the fact that Ethernet switching and other Ethernet technologies have done away with a lot of collisions that were the banes of network engineers until 15 or 20 years ago. Although FDI networks utilize ring topology logically as well as physically, they differ from token ring networks. A token ring network sends data logically in a ring fashion, meaning that the token goes to each computer, one at a time, and continues in cycles. However, the token ring computer are physically connected in a star fashion. All computers in a token ring network are connected to a central connecting device known as a multi-station access unit, MAU. MSAU. You'll learn more about token ring in lesson 2. Defining Ethernet standards is next. Inshallah, Ya Rabbil Alameen. See how many minutes we've recorded. We've recorded 10 minutes.